In the vast emptiness of interstellar space, something extraordinary happened. A spacecraft, launched nearly half a century ago, humanity's farthest-reaching creation, stumbled upon something so strange, so inexplicable, that it's left scientists reeling and the world buzzing with questions. This isn't just a story of technology enduring the test of time. It's a cosmic mystery that could rewrite everything we thought we knew about the universe. Voyager 1, now over 15 billion miles from Earth, has been drifting through the void since 1977, a relic of human ambition, a time capsule from an era when disco ruled the airwaves and the Cold War shaped global tensions. Yet in 2024, this aging probe did something unthinkable. It sent back signals that defy explanation, signals that hint at something lurking in the darkness, something that might just change our understanding of reality itself. It was a quiet night at a mission control center, the air thick with the hum of computers and the faint scent of stale coffee. A veteran engineer, one of the few remaining from the original team that launched the spacecraft, sat at a modern workstation, its sleek monitors a stark contrast to the clunky machines of the 1970s. The screen flickered with incoming data, routine telemetry from a probe so distant that its signals take over 22 hours to reach Earth. But this wasn't routine. Buried within the stream of numbers was something odd, a faint, rhythmic pulse, a low-frequency hum that didn't belong. It wasn't random noise or the crackle of cosmic rays. It was structured, almost deliberate, repeating with a precision that made the engineer's heart race. This wasn't just data, it was a message from the edge of the unknown. The discovery sent a jolt through the team. Decades of predictable measurements, cosmic rays, magnetic fields, plasma density, had lulled the mission into a rhythm of quiet reliability. But now, the impossible had happened. The spacecraft, designed to follow a predetermined path through the interstellar void, had altered its course. Not a drastic shift, but a subtle, deliberate adjustment, uncommanded by anyone on Earth. The thrusters had fired in a precise sequence, tilting on the probe's antenna toward a patch of space that, to every telescope on Earth, appeared utterly empty. No stars, no galaxies, no known phenomena, just darkness. And yet the timing was chilling. The mysterious hum had begun just days before the course change, as if the two events were connected, as if something out there had caught Voyager's attention. The mission control room transformed into a hive of activity. Scientists from across disciplines, plasma physicists, radio astronomers, signal processing experts, gathered around glowing screens, their faces etched with a mix of excitement and unease. The hum wasn't just a sound. It was a signal with mathematical precision, a pattern that repeated across multiple transmissions, ruling out interference or equipment failure. It pulsed at regular intervals, its frequency stable, yet unlike anything recorded in the spacecraft's 49-year journey. The team ran diagnostics, scouring decades-old manuals and modern algorithms to rule out glitches. The signal persisted, unwavering, as if demanding to be heard. Whispers spread among the team. Could this be a natural phenomenon, some undiscovered quirk of the interstellar medium? Or was it something else entirely, something that challenged the very boundaries of science? To understand the weight of this moment, we need to step back to the beginning, to a time when humanity dared to dream beyond the stars. The Voyager program was born in the early 1970s, a product of a rare cosmic alignment that occurs only once every 176 years. The outer planets, Jupiter, Saturn, Uranus, and Neptune, lined up in a way that allowed a single spacecraft to visit them all, using each planet's gravity to slingshot to the next. A young engineer, plotting orbital paths with a slide rule, first saw the opportunity, turning what could have been separate, costly missions into a grand tour of the solar system. Budget cuts and political debates nearly killed the plan, but a scaled-back version emerged. Two identical spacecraft, Voyager 1 and Voyager 2, tasked with exploring the outer planets and, if all went well, venturing beyond. Each Voyager was a marvel of engineering. A 1,820-pound machine that looked like a mechanical insect, with a 12-foot dish antenna as its face and a long boom extending like a proboscis to keep sensitive instruments clear of interference. Its brain was a computer with less processing power than a modern smartphone, and its power came from 3 radioisotope thermoelectric generators glowing with the heat of decaying plutonium. These generators, controversial even at the time due to their nuclear fuel, gave the spacecraft a lifespan far beyond what anyone imagined. Launched in 1977 from Cape Canaveral, atop roaring Titan rockets, the Voyagers carried not just scientific instruments, but a golden record, a gold-plated disc, etched with sounds, music, greetings in 55 languages, and images of Earth. It was a message to the cosmos, a snapshot of humanity for any intelligence that might one day find it. The early years of the mission were a triumph. When Voyager 1 reached Jupiter in 1979, its cameras revealed a world of breathtaking beauty, swirling clouds, storms the size of planets, and a great red spot that churned with ferocious energy. But it was Jupiter's moon Io that stole the show. Expected to be a dead, cratered rock, Io was instead a volcanic hellscape, spewing sulfur plumes hundreds of miles into space. It was the first time active volcanoes had been seen beyond Earth, a discovery that rewrote textbooks and ignited imaginations. The control room buzzed with excitement, scientists cheering as each new image appeared line by line on their screens. The air crackled with the thrill of discovery, the sense that humanity was seeing something no one had ever seen before. Saturn was next in 1980, and it delivered wonders of its own. The rings, long thought to be simple bands, revealed themselves as thousands of intricate ringlets, woven with mysterious spokes and braided patterns that defied explanation. Saturn's moon Titan, cloaked in a thick orange atmosphere, hinted at chemical processes that might mirror the origins of life on Earth. The discoveries poured in, each one a testament to human ingenuity and curiosity. The world watched, captivated, as images of distant worlds filled television screens and newspaper headlines. For a moment, the divisions of Earth, war, politics, rivalry, faded in the face of shared wonder. After Saturn, Voyager 1's path took it upward, out of the ecliptic plane where the planets orbit, toward the vast emptiness beyond. Its twin, Voyager 2, continued to Uranus and Neptune. But for Voyager 1, the planetary phase was over. In 1990, before its cameras were shut down to save power, the spacecraft turned back for one final act, a family portrait of the solar system. From 3.7 billion miles away, it captured Earth as a pale blue dot, a single pixel suspended in a sunbeam. The image, championed by a visionary scientist, became an icon, a humbling reminder of our fragility and our unity. "That's home," he said. "That's us. On it, everyone you love, everyone you know, everyone you ever heard of, lived out their lives." The cameras powered down, their work done, but Voyager 1's journey was far from over. As the decades passed, the spacecraft ventured deeper into the unknown, its instruments measuring the thinning solar wind, the fading influence of our star. Its power supply dwindled, losing about 4 watts a year, forcing engineers to make tough choices, shutting off heaters, dimming systems, stretching every ounce of energy. Yet the probe endured, a testament to the brilliance of its creators. By 2012, after 35 years of travel, it crossed a historic threshold, the heliopause, the boundary where the solar wind gives way to the interstellar medium. Voyager 1 became the first human-made object to enter interstellar space, surrounded by particles and fields from distant stars, a realm no telescope could fully probe. The world celebrated not with fanfare but with quiet awe, as humanity's reach extended beyond the sun's embrace. The data from this new frontier was sparse but profound. Cosmic rays surged, magnetic fields twisted in unexpected ways, and the plasma of interstellar space hummed with a density far greater than inside the heliosphere. Each transmission, crawling at 160 bits per second slower than a dial-up modem, took over 21 hours to reach Earth, captured by giant radio dishes in California, Spain, and Australia. The signals were faint, measured in zeptawatts, yet they carried secrets of a realm humanity had never touched. The mission team, a mix of veterans and newcomers, worked in a control room that blended old and new, modern screens alongside equipment kept alive just for Voyager. They described the spacecraft as an elderly relative, frail but resilient, still whispering truths from the edge of the cosmos. Then came 2024, and everything changed. The hum, the course change, the strange patterns in the signals, they shattered the mission's quiet routine. The hum was the first clue detected by the plasma wave instrument, a faint oscillation that pulsed with eerie regularity. It wasn't the chaotic noise of cosmic rays or the static of a dying system. It was ordered, almost musical, like a heartbeat in the void. Engineers checked and rechecked, ruling out interference from Earth or the spacecraft's own systems. The signal held steady, repeating across weeks of transmissions, its frequency stable yet unlike any known cosmic phenomenon. The team compared it to everything in their databases: pulsars, magnetars, distant galaxies. Nothing matched. The course change was even more unsettling. Voyager 1's thrusters, designed to keep its antenna pointed at Earth, had fired without command, shifting its orientation by a fraction of a degree. It was a small adjustment, but in the vastness of space, even a tiny shift could send the probe on a new trajectory over millennia. The thrusters had fired in a precise pattern, not the random bursts of a malfunction. Stranger still, the shift pointed the spacecraft's dormant camera platform toward a region of space that appeared empty to every instrument on Earth. No stars, no nebulae, nothing to explain why Voyager had turned. The timing, days after the hum began, suggested a connection. But what? Had the spacecraft detected something invisible, something that triggered an autonomous response? The team dug deeper, analyzing the telemetry for clues. They found subtle modulations in the radio signals, variations in timing and frequency that formed patterns too complex to be random. These weren't just distortions, they were structured, almost like a code. When plotted, the patterns revealed geometric ratios, symmetrical intervals, sequences that looped back on themselves in ways that seemed deliberate. Some sequences even echoed parts of Voyager's own transmissions, as if something was mimicking or responding to the spacecraft's signals. The discovery sent chills through the team. One analyst, staring at the data, whispered, "It's like it's talking back." The patterns bore an eerie resemblance to a signal humanity had sent decades earlier. The Arecibo message, a radio burst aimed at a distant star cluster in 1974, designed to demonstrate human intelligence to any extraterrestrial listeners. The similarities were faint but undeniable, sparking heated debates. Could this be a response, a cosmic echo from some distant intelligence? Or was it a natural phenomenon, a plasma wave or magnetic anomaly that happened to mimic structured signals? Skeptics argued for caution, pointing to the spacecraft's age. Its systems were 49 years old, battered by cosmic radiation and operating at temperatures far below their design. Glitches could create illusions of order, but the patterns were too persistent, too precise, to dismiss easily. A global effort sprang to life. Universities, research institutes, and independent scientists joined the analysis, poring over the publicly released data. Cryptographers searched for meaning in the signal patterns, while AI specialists ran algorithms to detect hidden structures. Plasma physicists modeled the interstellar medium, looking for natural explanations, perhaps an unknown type of plasma oscillation or a magnetic field interaction. SETI researchers, cautious but intrigued, dusted off protocols for evaluating potential non-human signals. The scientific community split into camps. Those who saw a technical glitch, those who saw a new natural phenomenon, and a daring few who wondered if Voyager had stumbled upon something truly alien. The public, too, was captivated. News outlets ran headlines like, "Voyager's strange signal. Is something out there?" Social media exploded with theories, from the plausible to the fantastical. Some saw the hand of extraterrestrial intelligence. Others saw a dying spacecraft crying out in its final moments. The mystery tapped into a primal human need to know if we're alone, to understand our place in the cosmos. For every scientist urging restraint, there was a dreamer asking, "What if?" The debate spilled into journals, conferences, and late-night discussions in mission control, where the air grew heavy with the weight of possibility. At the heart of the mystery is Voyager itself, a machine that has outlived its creator's wildest dreams. Its power supply, those plutonium-powered generators, now produces less than half its original 470 watts, dimming by 4 watts a year. Engineers have performed miracles to keep it alive, shutting off non-essential systems, running instruments at temperatures as low as minus 110 degrees Fahrenheit. Every 6 months, the spacecraft performs a delicate role to keep its antenna aligned with Earth, burning precious hydrazine fuel that can't be replenished. The team estimates the fuel will last until 2040, but the power will likely give out first, sometime between 2025 and 2030. When it does, Voyager will fall silent, drifting forever through the stars, carrying its golden record into eternity. The spacecraft's resilience is a testament to human ingenuity. Designed in an era of slide rules and punch cards, it has endured cosmic radiation, near absolute zero temperatures, and the relentless passage of time. Its instruments, cosmic ray detectors, plasma wave sensors, magnetometers, still send back data, painting a picture of interstellar space that no other mission can match. The team that tends it, a mix of grey-haired veterans and young engineers born after the launch, speaks of Voyager with reverence. It's like caring for a piece of history, one said, a part of us that's out there, still exploring. What did Voyager 1 encounter in the darkness? The hum, the course change, the patterned signals. They could be the final gasps of an aging machine, its circuits fraying under the strain of decades. They could be a new natural phenomenon, a wrinkle in the fabric of interstellar space that we've never seen before. Or, in the boldest dreams of scientists and storytellers alike, they could be something more, a sign that we're not alone, that something out there has noticed our tiny probe and reached out across the void. The truth remains elusive, but the questions themselves are a gift, pushing science to its limits and igniting wonder in millions. The mission's legacy is already secure. Voyager 1 gave us Jupiter's volcanoes, Saturn's rings, the pale blue dot. It showed us that exploration is more than data. It's a human urge to reach beyond, to ask what lies over the next horizon. Its golden record, with its songs and greetings, may outlast Earth itself, a whisper of humanity, traveling through the galaxy for billions of years. In 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445, a fleeting visitor in a cosmic sea. Long after its power fades, it will carry our story into the unknown, a silent ambassador of a species that dared to dream. For now, the mystery deepens. Scientists continue to analyze the signals, running simulations, testing theories, chasing answers. Each new transmission from Voyager is a treasure, a fragile link to a machine that has seen more of the universe than any human ever will. The hum persists, the patterns evolve, and the course change remains unexplained. Is it a glitch, a phenomenon, or a message? The answer could redefine our place in the cosmos, or remind us how much we still have to learn. Either way, Voyager 1 has done what it was always meant to do. It has pushed the boundaries of what's possible, forcing us to confront the vastness of the unknown and the courage it takes to explore it. This is more than a scientific puzzle. It's a story of humanity's relentless curiosity, our refusal to stay still, our need to know what lies beyond the stars. Voyager 1, a 1,820-pound machine launched in a world that no longer exists, has carried us to the edge of interstellar space, and now, perhaps, to the edge of something even greater. What did it find out there in the darkness? What called to it across the void? The answers may be years away, or they may never come. But the questions, these beautiful, haunting questions, remind us why we explore, why we build, why we dream. They remind us that the universe is vast, and we are small, but our reach is infinite.